With BPMN, you as a business analyst are able to portray the complex reality into a simple BPMN diagram, hence making reality visible and making it possible for you to see and understand issues in the business process within your company, bottlenecks, chances and risks overall. Let me show with an example what I exactly mean. This BPMN diagram displays the loan request process within a bank. This is just an example for illustration purposes. Let's say there are just 3 roles within the bank: the back office, the compliance and the client advisor. Let's say a client wants to have a loan, hence sends a loan request to the back office. This could be via application, via an app or via a letter. It doesn't matter right now. Let's say the back office employee has to check the documents and asks him or herself, are all documents okay? If that is the case, then the loan request goes to the compliance officer. Here, the compliance officer checks the background of the person, of the loan requester. After this, the client advisor comes into play and assesses the risk of the person who is requesting the loan. And if the client advisor thinks it's worth talking to the client in more detail, then the advisor is contacting the client, setting up a meeting or so, and that's it. So there are some next steps which I just exclude here for demonstration purposes, but let's assume that's the business process. The great thing with BPMN is now we have captured the complex reality, the current state, the as-is state of this business process. If we have a process engine or KPIs around, we could maybe see something like this. Let's say the bank receives 100 requests a day. And let's also assume the process takes on average 0.5 hours for each run, so 30 minutes. And let's assume the employees involved in this process on average make $30 an hour, meaning we have 100 runs every day. Let's take this times 0.5 hours, which one completion takes, which actually mean 50 hours a day. And as we know, $30 per hour is the average salary or hourly rate. Let's multiply this with the 50 hours and we get $1,500. So each day this process takes us $1,500. After we have understood this, we as a business analyst, or you as a business analyst, have the job to really think about, okay, based on this process diagram or this complex reality, what could we change to make the process more efficient in terms of time efficiency or lowering the costs or enhancing quality is also possible. And let's assume this assess risk task of the client advisor is something super manual. So the client advisor has to look through multiple Excel sheets, has to look or check in multiple systems just to get this value out, if it's worth talking to the client or not. And this could be a potential chance for you as a business analyst to optimize the business process. What if you could replace this manual task of assessing the risk with a simple API call? So if you change the system in a way that the client advisor doesn't have to check in these systems or in these Excel sheets, but just maybe has to press one button, an API call to various systems is done, and it returns a value which indicates if the client advisor should talk to this client in more detail or not. And this is the power why BPMN is so important, because it really shows you the reality, and you can manipulate the reality very easily without actually touching the reality itself, because everything is on a model and a diagram on paper first, so you can conceptually change the reality and find out what would be worth doing as a next step. If you also assume that maybe an API call or just a more automated solution can maybe put the time of this process in half, so not 30 minutes, just 15 minutes, this would mean per day we could save $750. So if it's $750 saved per day, let's assume we have 20 business days a month, this would equal $15,000 each month. $15,000 a month equals $180,000 a year. So if we assume that we could really decrease the time of this process in half by having the same amount of runs every day, we could actually save 180K a year each year, right? So you could think of what would it cost to actually establish such a solution so we are able to decrease the time of this process in half. And this could be actually an investment and return on investment actually. Let's assume it costs us maybe 200K to do this. After a year and a half, we actually get our money back because with these process improvements, we actually save some money. And so we have a great ROI on this case. As a business analyst, you really have the power to thrive internal case studies to actually optimize processes, lower costs, save some time, or actually increase the quality. And that's why BPMN is so important.
This video is the only BPMN tutorial you will ever need to watch if you are a beginner and want to get started with BPMN. This video won't be one of these super heavy theoretical videos. No. In the beginning of this video, I will very briefly explain what BPMN is and a bit of theory so you can understand what I'm talking about. And then we will together jump directly into practical examples and really step by step model business processes in BPMN and also execute these processes so you can really see how BPMN works in real life. That sounds interesting to you? Keep watching. Let's get started right away. As you probably know, BPMN stands for Business Process Model and Notation and is a worldwide adopted standard to model business processes, workflows, and activities based on certain rules and stuff like this. In this video, let me say a couple of sentences to the most important components and elements in BPMN. I won't tell you all elements which are out there. That's not needed. I just want to focus on the most important ones so we can get started right away with the practical examples. So what are these most important components of BPMN? The first group I want to present are the events. There are three kinds of it: the start, intermediate, and end event. Events are things that just happen or occur, right? Or for example, the start of a process is an event, process started. And also the end of a process is an event, process ended. But also, for example, 5 minutes are over is an event, right? So this is something that takes place in a specific point in time. These are events. That's the only thing you need to know for now. Then we have another major group, tasks or activities. Mainly tasks look like this: a rectangle with some round shapes and a couple of words in it. And tasks come in multiple forms. Again, there are so many, but I just want to introduce you to three important forms. The first one here with this hand symbol is a manual task. Manual task you could think about, for example, moving a rock from place A to place B is a manual task. No IT system is involved. Then we have user tasks. A user task means, okay, a user, like a human, is interacting with an IT system. For example, you're sitting in front of the computer, entering some data with the keyboard into a form. That's a perfect example for a user task. Then you have service tasks or very automated tasks. This means that a system is doing something in the background, automated, or some Java code, whatever, something technical. No human is involved, only IT systems are involved. So you can see there is a level of automation in these tasks. That's all you need to know for now. Then we have gateways, also very important. Gateways help us to basically make decisions or route us where to go in the business flow. There are multiple. I wanted to explain to you 4 different gateways for now. The first is the either-or gateway. That's basically like it says an either-or, right? So based on a certain condition, you would decide to go left or to go right. Only one way. Then we have the parallel gateway. This is there to actually have multiple tasks run in parallel, not sequential, in parallel. Later we will have some examples for this too. Then the OR gateway. This is a very complex concept to understand what the difference is between OR and an either or. Later in the examples you will definitely understand, but very briefly here, like I've said, an either or means you can just go left or right. There's no both. But with an OR, you can go also both ways, but you have to go at least one way. And then there is the event-based gateway, also a quite complex but also useful one. Here it's basically based on a certain event. So we are waiting for an event to happen. And if it happens, we go one way. If it does not happen, for example, or another condition is met, we go another route. But these are the most important gateways. I want to explain later more with some examples. Then the last bit of theory I want to discuss are pools and lanes. Basically, pools and lanes are there to describe different roles and to showcase who is doing what in a process. For example, here you can see we have two different pools, process A, process B, each one is a pool. And in process A, we have multiple roles, which are lanes in the end. And these two processes are communicating via the message flow. We have also a different kind of a flow, like an arrow, but you will see it later too. That's all the theory I wanted to cover for now. Everything I have explained now will be more easy when we do the examples right now. So let me jump to the tool. So here we are. And I want to explain with some easy examples the gateways and also the task and maybe the events that you have. So every process starts with an event and every process ends with an event. So I'm just directly creating it here. And let's have a very basic case study. Let's think about a bank who wants to approve a loan, okay? That's a very easy thing. So we could say we have a first activity where the bank user is entering loan details, okay? For example, we want to say you're entering the loan detail. For example, $1 million is the loan. And then based on the number, like if it's higher than something, higher than 1 million, we want to go route A, otherwise route B. This could be a good example for an X or for an either or. So let's do this example here. I'm very briefly modeling this example, and then we can execute it and see in real life how this looks like for the user. So let's do one thing. Okay, what do we do here? Just very easily creating some user tasks. That's too much. I'm just beautifying it a bit, and then I will explain again what we are doing here. So this is how a possible process could look like with an either or, right? So the idea is we're entering loan details. And now let's say if the loan is higher than a certain number, what do we want to do? You could have a send email task, right, to the boss or something like this. And if it's not, we could do something else. We could call the boss. So different activities based on the condition, right? So like I've said, a user task could potentially be a user form, like a form you're entering data. And that's what we're doing now. We want to create a form. So I'm just entering here the loan form, and we will create a form together. And let's say this form only has one information. It's the credit amount. And it's a number. And we make this field required, so the user has to enter it. Now going back here, like I've said, we want to say if the credit number is higher than 1 million, we want to send an email. If it's lower, we want to call the boss. Okay? So we have to now, here in the condition, enter this. It says if credit amount, let's say, is greater than 1 million, what we do is we send an email. Now this one, we could now specify if it's less than or equal, but I just click on default flow. This means just else, right? So here it was greater than 1 million. And this default flow is in any other case. If it's not more than 1 million, then we go this route. Now let me demonstrate you this use case, how this looks like for the real user. So I'm just starting my application here. The credit example is the workflow I'm choosing. That's the one I'm just doing here. Now entering loan details. So now I just get asked, what is the credit amount? Let's say it's 2 million, right? So now the amount is 2 million. I can complete. And what happens next? Now I got the send email activity. Why is that? Here you can see after entering the loan, it was larger than 1 million. So send email is the next activity. Here at this point, at this gateway, either this route or the route below is true, not both, only one. In this case, send email was the one. And if I complete this one very briefly, we see flow is done. Also, I can make the other example very quick. Let's say it's just $1, so a very low amount. Then we have the call boss activity, right? You see the other path was chosen, only one again. Okay. That's the X or the either or, which I wanted to explain very briefly. Now let's change things a little bit. Let's use the parallel gateway. Okay. So what we could do is, let's call this just, I want to explain the parallel gateway now. Just binding this here. Okay, cool. So what do we want to do? Let's say we are changing this gateway and this gateway to the parallel one. So now these conditions, we're going to remove it. That's not needed. It doesn't make any sense for now. Is there anything in? Don't think so. Let me quickly remove it so it looks just better. Okay, that looks better. So what does this mean now? In this example, now we have changed the either or gateway to parallel. This means we are entering the loan details, and then in parallel, these two activities are open. And only if both of these activities, send email and call boss, both are done, only then the user task here gets started. So whenever one of these two is not completed, we are not able to proceed at this step under no condition. So let's save this again and publish it. So you can see how this looks like in real world for a user. Again, I'm starting the example. The credit amount doesn't make any difference for now because we have removed this condition. Now I've completed this step, and as you can see, both activities, call boss and send email, both are now open for me to take, right? And so you can see here, both are in green because both are now active. And when I decide to complete this one, you can see send email is still open. And until this one is not closed, we are not able to proceed. So you could imagine if someone is never doing this, this process never will be closed, which is potentially a bad thing, just to keep in mind. But this is how the parallel gateway works. I hope this makes sense to you. If I complete this, now the last task is here. I can complete that and everything is done. This was the parallel gateway. Now, we wanted to discuss the OR gateway, the inclusive OR. Let me here again switch very basically these gateways. So now we have these inclusive OR gateways here. What does this mean? Like I've said, for the either or, only one path is valid. For this inclusive OR, at least one path has to be chosen, but all can be chosen, right? So what does this mean? Again, we need some conditions here. Let me, for example, put the following condition. If the credit amount is greater than 100, right? So this path is greater than 100. Then we go this route. But now here in this condition, we could say if the credit amount is greater than 1000, then we want to go this direction here down. And as you can imagine, if the value is, for example, 1 million, what is true? Both are true, so both paths will be chosen. For the XOR gateway, this is not possible because in the XOR, it's seen like an if, else if, so only one is possible. But here, multiple are possible. Let me show you this again in reality. How does this look like? Saving, I'm just deploying the app, and then we can run. That's fine. Let me open the credit example. So, like I've said, let's make it easy, okay? Let's take 150 for now. And as you can see, as only the first condition was met, only the first task, send email, is there, right? $150 I've entered, and this makes sense. Let's finish it. That's okay. And now let me again put another value. So let's put 2000, right? What happens then? Exactly, both paths will be chosen. Like I've said, as you can see, if it's over 100, we go this way. If it's over 1000, we go this way. In this case, both are true and both will be chosen. But only one is also possible, right? So that's the OR gateway. I know it's a bit complex to understand, but that's basically it. I hope you got it. I hope you got this one. Let me know in the comments too. So now the very last thing I want to do with you is the event-based gateway. And this one is a bit more complex to model, so we'll just take a bit more time for this one. So let's do one thing. Oh, so for now we can again enter these details, and let's say then the event-based gateway is the following here. And this is just demonstrating we are waiting for something to happen, okay? So one possible outcome could be either catching a certain signal. So for example, another workflow has to do something, we're waiting for it. And we also want to have an alternative, like a timeout, right? So if nothing is coming, we also want to proceed in some way, right? So we want to have a timeout, for example. So let's say here in duration, let's say 1 minute. We're waiting for 1 minute. That's a good idea, right? So we have a timeout after 1 minute. I can call it after 1 minute. Now we have to name this signal. Let's call it just signal or signal 1. It's a good thing. Right. And if signal 1 is occurring, right? If signal 1 is coming into, we want to have the activity call boss. And if it's not coming in, but 1 minute, if signal 1 is not coming in under 60 seconds, we want to go the alternative path as a timeout. Send email or so, something like this. And then we can say whatever, we just close it this way. This could be a potential use case for the event-based gateway. Now, as I've mentioned, a signal is coming from a different process, so I have to quickly create a different process to do this. So that's the signal process flow. Let me quickly enter something. All right. So let's say this flow is just a dummy, right? So we're just doing something, and then we will send this signal here. Let's also call it signal 1, so we know which one it is. And I'm also referring to it as signal 1. That's important because this signal 1 and this signal 1 is the same, right? So they have to match. And yeah, this should be good enough. So let's save it, deploy it. All right. All right, so now I'm in the application. Let's start the following. So we're starting the credit example. Just entering some loan. As you can see now here, it's waiting for the signal or for the timeout. Any of these options have to occur. Now let's start the signal process. Just finish it very quickly. And now we go back here. You see the signal was catched because now call boss activity is open. And that's here, right? So the signal was successfully catched. So multiple processes were able to communicate right now. That's awesome. We can finish it. That's fine. Now we also want to check if the timeout is working, right? So I'm starting a new flow. Here in history, now it's again waiting for the signal to occur or this 1 minute to pass. This time we will just wait for 60 seconds. So the timeout is winning and send email is the activity I'm expecting. So let's wait for a couple of seconds. All right, so as you've seen, 1 minute is done. And here the path is going to send email. So I'm expecting this as open task. And yeah, the task is open. And so yeah, it worked perfectly fine. I can complete it and the whole flow is done again. And that's the event-based gateway in action. So now I've demonstrated you the important gateways that we have, the tasks and events. I hope this makes sense to you. If you're interested in more BPMN content, let me know down below. That's it for now. Take care. Bye-bye.
This is the only BPMN tutorial you need to watch in order to understand all BPMN events, all BPMN tasks, and all BPMN gateways. Let's get started right away. So here you can see all BPMN events that exist.
our start events, end event, and intermediate events. Here in red, or in the red box, you can see the catching events that we have, in blue the throwing ones, and in green the non-interrupting. So what does this actually mean? The catching ones are events which means we are receiving something or we are catching something. So let's go one by one so we can understand each of them. The first is the message event. As you can see, there is a catching, a throwing, and a non-interrupting way. A message event just means, or an event in general means, just something happens in a specific point in time. It has no duration, it just happens, right? So if you hear a sound, it just happened. This is an event. Or if the time is 12 o'clock, it's an event, it just happened. And the message event is just that a message got received. The first icon here in the catching is the message start event. So a process gets started by receiving a message. The second event is also catching. This means the process is catching a message during the process because of the two lines around the letter symbol, the two lines. This means this is an intermediate event. So during the process, this happens. Then we have the throwing events. Throwing events are always more black or more filled from a color perspective. So the black letter here with two lines means we are sending a message, not receiving, we are sending a message during the process. And with the thick black line here, this is an end event. So we are finishing the process with a throwing message we send out to someone else. Then we have non-interrupting. So it means later in this video, I will show you what exactly non-interrupting events are, but you can recognize them by these two lines, which are dotted, so to speak. They're not solid, they are more dotted with spaces in between. And this means later it's not interrupting the process, but later more to this. Then the next category of events is the timer event. This is not like a message, it's like a time has arrived, so to speak. The first event here means, let's say if it's 12 o'clock, then the process starts. That's this point here. And also during a process, we could wait. Let's say it's 1 p.m. and after this we proceed. For the timer event, you only have catching but not throwing events because it doesn't make sense to throw a time to someone else. But also we have an non-interrupting event, which I will show later. Then we have error events. What is an error event? Whenever there is a mistake, you could use an error event for this. So to speak, if an error is received, the process starts. For example, it's the first event here. Or during the process, we could receive or catch an error. But also we can end our process with an error. So to speak, if something happens, we send an error out and then we finish the process. There is no non-interrupting because an error per definition means the thing or the process gets stopped as soon as we send it. Okay, then we have escalation. Escalation events are kind of similar to message events up here, but a bit different because you could use it more specifically for escalating processes to a supervisor. So for example, if an escalation event was received here, it starts a process, or during the process it could be received, or we can send an escalation. Let's say during the process something happens and then we escalate or we send an escalation, so a new process gets triggered. It's kind of like the message, but it's just more specific. Okay, then we have the cancel event. This is very specific also. For example, you could imagine whenever you use a tool, you always have a cancel button, right? Or a cancel option. And that's the same here. We can receive cancellations and we can also have an end event as a cancellation. Then compensation, this is very specific. So a compensation generally means you want to undo what you did before. This is especially helpful for database transactions or if you book a flight transaction, kind of like. So whenever we have these events, we try to undo what we did before. I have an example for this later too. Then we have conditional events. And a conditional event is very generic. It could be almost everything. Any condition, like one condition could be if the variable x equals 10, then we're going to do something. Or when the car arrives, whatever. Any condition could be a conditional event. Then we have links. Links are very rare. You will very rarely find these events. For example, a good use case is if you draw a BPMN diagram on paper and the paper is too small, you use these events to link on the next paper where the process proceeds. So it's very uncommon to use it. Then we have signal events. This is kind of like a message, just without the message, if this makes sense. So you're giving a signal like something happened, but you don't have the message itself to communicate what exactly happened. So it's just a signal received or not, right? So you could get a signal here, or you can send a signal to somewhere else, but no message is attached to this. Then we have the terminate end event, very special because it's just an end event. There's no catching and no interrupting. Terminate means when this is an end event, every token in this process gets killed and terminated. Then we have multiple events. A multiple event could mean that multiple things at the same time occur. It's not, or for example, if we start the process with this, we could start a process with the time or the message. But if you want to do multiple, like a process can be started with if it's 12 o'clock or if a message is received, we just want to use one symbol, we could use this here. And also we can end a process with multiple events. Then we have the parallel multiple. This means, for example, if it has to be 12 o'clock and we need to receive a message, both, not just one, then we could utilize the parallel multiple event. For example, here is a start event. All right, so these are all the events we have. Like I said, we have catching events. So when we receive something in our process, we have throwing events. So when we end our process or when we want to send something out. And for some events, we have a non-interrupting option. What this exactly is, I will show in some examples later. Now let's have a look on tasks and activities in BPMN. Like, these are the most usual ones. Top left is the abstract task. This is just a generic placeholder. Then we have receive tasks, so we can receive messages with a task. We can send messages with a task. We can have service tasks. So whenever a system is fully automated doing something, we would use this one. We have user tasks. So if a user is doing something with the IT system, let's say enter a form. We have manual tasks. This could be like moving a rock from a place to B or moving a piece of paper somewhere. This could be a manual task. A business rule task, I have an example for this. This is to simplify the BPMN diagram if you have a lot of decisions left, like XORs, XORs, either ORs. And script task is if a little script is used for this task, but not really fully automated service tasks. Let me give you a quick example what a business rule task does. Here you can see, for example, a BPMN diagram, which has a lot of XORs, a lot of decisions. And as you can imagine, this logic really blows up the diagram and makes it less readable. And instead of using this, you can also just use the business rule task here, which has these rules in it. Like you could imagine, right? You capture some information, let's say the color of an object, the size of an object, and how old it is. And based on what the outcome is, you could categorize it for a certain way, right? If it's old, green, and big, then you have this state here. If it's blue, small, and young, it's here, right? So it's very simplifying the model because in this business rule task, you can portray these decisions to make it more lean. That's how you use the business rule task. Okay, let's jump back to the activities. What also kind of activities we have, you can see on the right. We have the parallel task, sequential task, and the looped task. What are these here? So here on the right, these three options you can combine with what you have here on the left. So you could have a user task, which is also sequential, so to speak. So what is a sequential task? You could imagine you have a list, like an input list. And with the sequential task, you have to do your task for all the items of this list. Let's say we have a list of tree, vehicle, and potatoes, and the activity is to buy it. Then this means this activity is buying the vehicle, then the potato, then the car, or whatever the order is, in sequence, one after the other. And when this is done, the activity is done. The parallel task here means we're not buying the list in sequence, it's in parallel. So we're buying potatoes, the car, and whatever option we had in parallel. Then here is the looped task. What does this mean? I have an example prepared. you could imagine you do something, do A, then is it fine or not? If not, you do A again. And if it's fine, you go to do B. And the same could be done with this looped activity. You do A until something happens, right? You have to define an anchor. When is something done, so to speak? So the cashier is maybe scanning an object until it really scans. You know what I mean? And if this is done, we go to activity B. That's the looped task. All right, then here on the bottom, there's again one category of tasks missing. It's here on the left, it's the sub-process. So every activity could be a sub-process in itself. So you could collapse this plus here and you would get what you see here in the middle. So this activity in itself is another process with a start, with an activity, and with an end. This helps to build hierarchies between processes to keep the high-level process lean. This hierarchy is very necessary. Then here on the right, you have the call activity. It's also like a sub-process, but you could imagine this call activity, like this activity or this process is somewhere defined, not in this process, it's just somewhere defined somewhere else, and you just call it, right? You just make a call to this activity. This helps if you store your processes in several places or in several units, then you can just simply call them without defining them themselves. A normal sub-process, like here on the left, would be defined in the high-level process. And if you reuse it often, it would make sense to make a call activity for this. Okay, I think that's everything you need to know about activities. Now let's have a quick example where this is meshed in. So you have a start on the left, end on the right. So you do something manually. Here's this hand symbol for manual task. You do it in the loop until something is happening. Then B happens, so do B, the service is doing it full automatically. So this user has not to do anything. And then we do C, which is a sub-process in a call activity. So we're calling a process, whatever this process does. And after that is done, the process here is finished. Cool. Let's now combine tasks and events together. As you can see here on the left, we have do A, do B, and do C activities. Usually, now you can see here we have this timer event, which is an interrupting event. What does this mean? You can see this event here has solid lines, and here on the right, it has dotted lines. The solid lines means it's an interrupting event. So we are doing A, and after 10 minutes, if A is not done, we are still in A, and after 10 minutes, this interrupting event gets triggered, meaning we will leave activity A, so we stop activity A, and we will do activity C. Activity B, in this case, will never be conducted. However, if we finish A before the 10 minutes, then we will do activity B. In contrast, on the right side here, we have this non-interrupting event. So this means we do A, and after 10 minutes, this non-interrupting event gets triggered, so we will do C, but we will not interrupt A. This means in the end, we will do activity A, activity B, and activity C, because this timer event here is non-interrupting. However, if we finish activity A before the 10 minutes have passed, then we will do activity B, and activity C never gets conducted. That's the difference between non-interrupting events here on the right and interrupting events here on the left. Of course, you could use, instead of a timer event, anything else, like a message event, like a signal event, whatever you want to use for. I'll also have prepared an example with an error and compensation event. So let's say we do A, and while we do A, it might happen that an error occurs. And in this case, we catch this error here with this interrupting error event. And whenever an error gets catched, we have the compensation end event. So we are trying to compensate what happened before. So let's say do A has written something into a database or has written something into somewhere else. And if we have an error here, we try to compensate for this. So we try to reverse it or undo it. However, while doing A, if no error occurs, we just do B. And the path down here will never be conducted. That's how you could use catching error events and compensation. Now let's have a look on the gateways BPMN has to offer. The very first one, I'm sure you know, the exclusive or the either or gateway, with two symbols. Either it's this gateway symbol without any filling, or it has an X. And as you know, the exclusive OR gateway means only one path of here can be chosen. For example, is the traffic light green? Yes or no. Only one is true, never two. Or you could make a different decision. Is the variable equals to 1 or is it else, right? So you have only one path is true and valid. Then we have the event-based gateway, also two representations here. And the event-based gateway is based on the events. So let's say you could wait for a call to happen or for a time to pass. And whatever happens, the event-based gateway is routing you the right way. Then you have the parallel event-based gateway. In contrast to the event-based gateway, now multiple events should happen before we can proceed. So it's not like only the time has to occur or a message has to be received. Both now. With the parallel event-based gateway, we only move on, for example, if it's 12 o'clock and the event of a message occurred. Only then. That's the parallel event-based gateway. Then we have the inclusive gateway. The inclusive OR is different to the either OR here on the top. The reason is the either OR only allows one path to be chosen. The inclusive OR means at least one path has to be chosen, sometimes more than one path. It depends on the conditions you have on each path. So whenever we say, today I go to the cinema or I go to the bakery, usually in normal language, we mean an either or, so we do one of the two. But if you model an inclusive OR, we could do actually both, but at least one of these two activities. Then we have the complex gateway, and the complex gateway is you use it whenever you cannot use anything else. Because with the complex gateway, you can define the rule in the gateway itself. Let's say, for example, you send out messages and you can receive back the answer from someone, but as soon as you have two answers from however many people, then you want to proceed, right? It could be like 10 answers come back, but as soon as you have two, you move on with the process. In such a scenario, you would use the complex gateway. And last but not least, the parallel gateway. I'm sure you are familiar with this too. We use this one to parallelize activities, to make them parallel. So not sequential, but parallel. So let's say we have an activity for system A and for system B. They both do it in parallel, and we only move on in the process as soon as both systems have completed their activity used by this parallel gateway. I also link you some videos in the description below I've made before to understand each gateway even better. All right, let me show you everything you need to know in order to understand BPMN gateways. In order to do this, I've prepared 3 diagrams for you. One diagram to explain the inclusive OR, one diagram the parallel gateway, and one diagram to explain the XOR and the event-based gateway. All right, what is this process about? So in this diagram here, this diagram is about submitting a loan request or a credit request in a bank, so to speak, and someone has to approve it. So in this process, you could imagine the first step is to submit a request. I will show you exactly how this looks like. After we submit the request, the system is waiting for an event. 2 events are currently possible. The event down below here is a signal receiving event. This means if another system is sending a signal that the decision has been made automatically, we go this route, and then the process will be done in the sense of a request straight through processing. Or the alternative, if the decision was not made by another system, we have 10 seconds passed. In this example, it's just 10 seconds, but you could imagine a week. So if no system is approving it, we go this route, and then the user has to check the request, let's say another team member, and has to decide if he wants to reject or approve the request. So this is this process here. Then the second process, which interacts with this one here, I'm going to execute it in a second for you. Like I've mentioned, another system can make a decision, and this process is this other system actually. It's just sending a signal like here, and this signal which is sent here is going to be received here. That's this diagram. And the last diagram we do in the end, I'm going to show you also a request to submit this. All right, let me demonstrate this for you guys. So I will just start this process in my process engine. As you can see, the process is started. Currently, the token is here, submit request. So this activity has to be done next. So what I'm going to do is I'm going to refresh my task list, and you can see submit request is the activity here.
So I'm gonna claim this activity. And as you can see in the model, submit request is an activity. And this activity looks like this. There's just one attribute, the credit amount I have to enter here. Let's say I enter 10,000. In real life, of course, we would have a form here with like 10 fields or even more. For this demonstration purposes, I just have one field, the credit amount. So let's say it's 10,000 and I complete this. What you can see here when I refresh the diagram, now the token is at the event-based gateway. Now two things happen. Either the time is passing or another system is interacting here. So let's assume this other system is interacting. So I just call this process. And this process in the end calls or sends the signal, which is gonna be received here. So when I now refresh this page, you can see the token is gone because decision received and actually request straight through processed. So there's no other activity, so the token is gone. In this case, the system received the decision and the process is over. That's this case. Now let's also test the case above if no system is interacting and we have a timeout, so to speak, so 10 seconds pass. Let me demonstrate this for you too. So I'm gonna start this process again. I'm gonna refresh my task list here. And again, I can enter an amount, doesn't matter really. And again, when I show this to you, you should see exactly here. It's now waiting for an event. This time, I'm not going to use the other system or the other process to make a decision. I'm gonna wait. So this means actually, after the time has passed, the user again has to do an interaction. So let's quickly wait for this to happen. All right, as you have seen here, 10 seconds passed and now the token is in the check request activity. I'll check my task list and I can see check request activity a few seconds ago. So I can open it. And what it is, this form is very simple. Also, I can see the requested credit amount of 5,000. And here's the question, do you approve this request, yes or no? I can do either way. Let me just go with no and I'll complete it. And when I go back to the process here, you can see the token is gone. So this process is done. The same would happen if I had done yes, then we had approved, but I did reject, so no, so it's request rejected. So this process is done in both ways. This is how you use the event-based and the XOR gateway in a practical example. So how did we actually implement this? When I click on these receiving or catching events, like this one, the time one, I can see this one is like listening. As soon as the token is at the event-based gateway, we're gonna wait for a duration of 10 seconds. This here is an ISO norm, which just means it's 10 seconds of time. You could also implement other rules like 1 day, 24 hours, 1 hour, whatever. Or besides duration, you could also pick a date. So if there's a specific date met or in a cycle, you can ask for cycles. Exactly. And then this one here, this is a signal. Actually, it's just listening on a global variable. So there's a variable called signal. And as soon as this process is catching this variable, then the process moves on. And here in this process, in the end, I'm sending the signal, so to speak. So it's very important that the name here and the name over here are the exact same. So the system knows how to match them. And how do we actually implement the X or either or gateway? This was also quite simple. Here in this task, we have an attribute is approved. If you remember, we had the question, do you approve this request? And there are two values, yes and no. Yes and no here, so to speak, is the enumeration values. And in this XOR gateway, we are asking for this value. So actually here you can see is approved equals yes, then we go this route. And if it's no, we go the other route. This is how the XOR gateway is operating. So this is a real if then else statement, so to speak. And the event-based gateway is a bit more complex. It's really listening if an event is occurring. All right, then this was the helper process to send the signal. And here I used the parallel gateway. So to speak, you could see it like this. Whenever this process is kicked in parallel, these two activities, let's for example say an email is sent and a database is updated, both happen parallel. And only if both tasks gets successfully closed, only then we are sending the signal. This is how the parallel gateway works. Everything between these brackets here
happen in parallel, and the process can only proceed only then if all are done. That's the parallel gateway. Now let me show you a different case I've prepared for you, this time with the inclusive OR. It's a kind of like similar scenario. Again, it's about submitting a credit request. So the user is submitting something, and based on the amount submitted, we have different routes. So if it's a lower amount, below 25,000, then we want to have a check request by a peer member. If it's above 25K, the team lead is going to check the request. And if it's above 50K, we have the manager to do it. So what is now special about the inclusive OR? As you can see, let's say the amount is 100,000. What is going to happen? What do you think? I'll give you a couple of seconds to think about this. Or maybe you can stop the video. I'm going to explain. If the amount is over 50K, let's say 100,000, then both of these flows here are going to validate to true because both is right. So both will happen. So both activities are going to get started. And that's the tricky thing about the inclusive OR. More than one path are going to be followed, or at least one, you could say. At least one path will be followed. In some cases, more than one, and some only one. And with the either or, if you remember here, it's just exactly one, never both, never, okay? All right, and of course, if the amount is very low, then only this path here is gonna get chosen. So let me also demonstrate this case for you. So I'm gonna start it again in my engine. Exactly, so that's the process now. Submit credit is the activity. Let me refresh the task list, submit credit, exactly. So what we're gonna do is, let's make a low amount for now. So 10K first, complete it, refresh this one. And then you can see, because the amount is below 25K and this is the only condition which is met, this activity here, the peer request, is gonna get used. So I can open it, you can see check request peer. I'm opening this and whatever. Okay, and it's done. Now the token disappears. Perfect. So let's try the same now for the different flow. So I'm gonna start the diagram again, the model. I'm going to open this activity again. So let's now do something a bit more, but not fully. So let's go with 30K. 30K, what is going to happen? I made 30K, what is going to happen? I give you a couple of seconds to think about this. I'll stop the video. Exactly, how you've probably thought about this. 30K means the team lead has to request it. The peer is not doing it because we have the condition below or equal 25K. And a manager only gets involved when we have more than 50K. So it's just the team lead. And this is also what is happening here. So this activity for the team lead is active. So we're going to claim it and whatever. And it's done. Now, the last question, what's going to happen if I make a big amount? We have clarified this already, so you should know, I hope. We can quickly also play this through so you can see it in real life. How would this look like? So we're going to make 100K, right? Looks like this. And now, ta-da, you can see 2 tokens have been generated. An inclusive OR can create multiple tokens, although only one token is getting in. An XOR is not able to do this, right? An XOR is an XOR is able to get multiple tokens, but only is going to release one. That's the big difference between XOR, so the either or, and this one here, the inclusive OR. All right, now we have 2 tasks. We can also check this again in the engine. Exactly, team lead and manager both is there. And exactly, when we just accept it. So what's going to happen is now you can see one token has moved and the other one is still there. Also, a tricky thing about the inclusive OR, or something you can easily forget, is it's true, multiple tokens can be created, but after the inclusive OR, we will only proceed if all the tokens which have been created come together in the end. So in this case, it's not like that this token would go to the end and the other one would stay here. No, this token here is only moving as soon as the token above joins the inclusive OR. Okay, so that's also a big difference in specialty. So the manager exactly the same, and approving it, it's okay, and then we are gone. All right, of course, this example may not be the best to do in practice in the real world. Maybe you want to do the team lead only, and when he When he approves, then it goes to the manager, but I just took this example here to demonstrate the inclusive OR for you guys. Let me know in the comments. In this video, I'm going to show you the BPMN gateways, what exactly they stand for, and also how and when to use them with real-life examples. Let's jump right into it. First, what is a BPMN gateway? BPMN stands for Business Process Model and Notation, and is a standard for business process modeling. A BPMN gateway is a certain element within this modeling notation. Within the business process, a gateway is a decision point which influences which of the following paths in the business process will be passed next based on given conditions. Let me give you an example. When someone asks you if you also want to order a pizza, you ask yourself, am I hungry? Based on the outcome of this question, you decide whether you also order a pizza or not. This is a possible representation of a BPMN gateway, because based on the condition if you're hungry or not, you will decide which path you will go, either ordering or not. After clarifying what a BPMN gateway is, let me show you which BPMN gateways we have within the BPMN standard. There are mainly 5 BPMN gateways. Let me name the 5 first, and then I'll dive deeper into each of them. The first one is the either-or gateway, also called XOR gateway. Here we have 2 possible forms on how to model this gateway. It's also called the default gateway because it's so commonly used. The next one is the OR gateway. There is a very important difference between the OR and the either-or gateway. I will show you in a second. Then we have the parallel gateway, the event-based gateway, and the complex gateway. Now let me demonstrate you each of the BPMN gateways. The either-or gateway represents an either-or decision. We are using either-ors very often in a day, and it's pretty intuitive. Shall I wear the brown shoes or the black ones today? Is the light switch on or off? You would always use the either-or gateway when you want to represent the decision that from here only one path is valid and all the others are not. Let me explain this one. Imagine a self-driving car. While driving, the car is constantly checking traffic lights. After checking the traffic light, the question is, did the traffic light switch from green to yellow? Based on the observation of the car, there are only 2 options, either yes or not. When the answer is no, then the car keeps its speed, because the light won't turn to red. In case the traffic light switched from green to yellow, the car calculates its behavior, whether it should keep the speed, increase it, or start to slow down. Only one and exactly one path is valid here, never both. The question based on an either-or gateway doesn't have to be a yes or no question. Yes or no is just very simple to understand. This example is simplified, of course, but I think this should explain the concept of either-or BPMN gateways pretty good. Let me know in the comment section below if this makes sense to you. Alright, now it's time for the OR gateway. Like I've mentioned in the beginning, there is an important difference between either-or and OR. Usually in our daily conversations, we say OR, then we mean either-or. Therefore, we reference to the either-or BPMN gateway in usual language. The OR gateway is also called the inclusive OR. Why? Let me explain you again with an example. In the end of this video, you are probably going to evaluate this video. This video might be like-worthy to you, so you would like the video, or maybe even subscribe-worthy, so you would subscribe to the channel, or even something else. The key of the inclusive OR is that at least one path has to be chosen. You can also go multiple paths, or even all, but at least one. That's why we also call it the inclusive OR. To get the concept of this inclusive OR can be a bit hard, as we use OR, like I said, in our daily life as an either-or. Now let's jump to the next BPMN gateway. The parallel gateway is used when we want to represent activities that are getting worked on in parallel, not in sequence. A single person in general never does things in parallel. This would be real-time multitasking. We rather do things in sequence. But IT systems or activities conducted by different actors could run in parallel. Let me give you an example here. Let's assume you want to have a call with your boss regarding an event that you've planned. In order to do this, You first write an email to the assistant of your boss. This email needs an approval from the assistant. While the assistant is approving, you are in parallel preparing documents for the call with your boss. And when, and only when, you prepared the documents and you got the approval, only then you would call your boss. If you have prepared the documents before the approval has been given, you would wait before you would call your boss. Also the other way around, when the approval got submitted and you have not prepared the documents yet, you wouldn't call your boss either. The parallel BPMN gateway implies that you can only proceed further if all paths within the parallel gateways have been completed. Let me know in the comments if this makes sense to you. The next BPMN gateway is the event-based gateway. It also has a lot of similarities to the previous either-or gateway, because only one path is valid. Imagine the following scenario. It's Friday afternoon, and tonight there is a huge party from one of your working colleagues, but you told one of your friends, who is not really into parties, that you would want to join him for a chill evening, but your friend would need to tell you latest at 7 PM if he has time for this evening or not. The alternative would be the party. This scenario implied that we need a gateway which is referring to the event if your friend calls you before 7 PM or not. That's the way how we would model this scenario. We have the event-based gateway, and after this gateway we have these two possible events. The first event would be the call from your friend, and the second one would be the alternative, in case your friend wouldn't call at all. So it's 7 PM. We need this alternative, otherwise we would wait until forever. There is also a parallel event-based gateway. It's simply the combination of event-based gateways and also the opportunity to have parallel valid paths. But for now that's good. Let's jump to the complex BPMN gateway. Do you remember the either-or and the parallel gateway? The either-or described that only one path is valid, and the parallel gateway described that all paths have to be finished. The complex BPMN gateway is called complex because we can specify the logic every time we use it. Let me make an example here. Let's say we start a computer system. This system would now do some tasks in parallel. For now, let's call these tasks task A, B, and C. When we would use the parallel gateway, then the next steps would only be conducted when all three tasks are done. But let's say we already want to do another task as soon as 2 out of the 3 tasks are done. This is how we can use a complex BPMN gateway. This BPMN gateway is based on specification. That makes it very powerful, but also a bit complex. Which one of the BPMN gateways have you already used? And which ones are you going to use more often now?
Alright, have you always wondered what is the key difference between all the BPMN gateways out there? The either or, the parallel, the event-based, the complex, the inclusive or? Perfect, you're here with this whiteboard today. I'm gonna explain the difference between all these gateways, and in the end of this video you will leave with an understanding what the key differences are and how to use these gateways. So let's start right away. I just modeled a very simple process or a couple of process steps. So let's assume our process here, the first activity is to enter some data, whatever that is. Let's assume we are in an HR context. So we enter the data, then we have a gateway where a decision is made, and then we have follow-up activities. So let's say the either or gateway. So how does this look like? Actually, you could model it like this, just like this route here, or you could also put an X in the middle, then this is the either or. So what does this mean? So we're entering some data, and then here on this either or gateway, we can model a decision. So let's say when we enter the data, we enter something for, like, let's say there's a variable like maybe seniority, right? Seniority. And there's maybe junior, mid, and senior, okay? So there's a J, an M, or an S. That's the variable. And now we're asking here at this either or gateway, let's say seniority. So seniority equals junior question mark. So that's the question right now. Is the seniority we have entered here junior? If yes, we go this route on top. If else, so no, so it is medium or senior, we go down here. Okay, so in this either or, we have modeled this decision. So let's get a token. So the process starts, the process token moves on to enter the data. We enter the data with seniorities either J, M, or S. And then the token, based on this, we have the decision, what is it now? Is it S or is it not? The seniority. Excuse me, is it J or not? And if it is, we go up here and we do not go down here. So up here it would say contact HR, and if no, we contact the manager, right? So instantly, based on the data here, entered here, this either or gateway is routing us which way, and only one way is possible. All right, that's the either or. Now let's have a look on the parallel gateway. How does this look like? As you know, the parallel gateway looks a bit different. There's not an X in here, there is a plus symbol in here. So let's model it like this. There's a plus. Actually, you could make it a bit more good looking like this. So this is a plus. So what happens now is, here we could say like this. So we enter the token. So now, of course, if you have in parallel, this question, like the condition, is it seniority junior or not, doesn't make any sense anymore. So we can remove it. Because what happens now is, as soon as we enter the data, here this token gets here. And now the magic of the parallel gateway is it duplicates the token coming in. So instead of just having one token, we now have two tokens created by the process. And one token will go up here, and while one will go down here to this activity. And now we have two tokens in the process. And this is always tricky because if you use a parallel gateway, you always have to be able to manage these two tokens afterwards. So what you're going to do with them? What I recommend, let's say for now in this example, we use a closing parallel gateway. So we could say, zack, like this. Then we have here a closing parallel gateway, so to speak. And what happens now is, as soon as one activity is done, this token moves in here, and only when the second, which was created here, also arrives there, then we can move on with the process. But the process will, this token here, the green one, this token, will be stuck here until the purple one, the rosé one up there, also joins back. And only if all the tokens created by this here join back here, the process moves on. Okay, that was the parallel. Now let's have a look on the inclusive OR gateway. How does this look like? So just quickly erasing this stuff right here, and also right there, we don't need that for the moment. You know, the inclusive OR has this O shape. So it looks like an O inside of it. And what does this mean now? So this actually means we enter some data. Let's say the seniority field is not just one, you could have multiple seniorities. You could be junior and medium, you could be medium and senior, like there's a combination possible. And what you could do now is, for example, you ask, is the seniority equals junior here? And if it's junior and medium, you would go here, for example. So let me explain this one, this is very tricky. So let's say we enter junior and medium, and then like this token here, we enter, then we go to the inclusive OR. As we have entered junior and medium, what does this mean? So which is evaluating to true? Now actually both are evaluating to true. So we have junior and medium, and this one here is asking, okay, if it's junior, like if it's junior is in it, great, we go this route. And here we have modeled junior and medium, so if it's both, we go this route. So in this case, both is evaluating to true, hence we also have again two tokens, one going here and one going there. That's very tricky to understand because in the inclusive OR, multiple things can be true at the same time. That's a difference to the either OR, right? In the either OR, you just have one or the other, that's it. With the inclusive OR, you could have both technically. But also you could have just one. Huh? Let's assume for the moment we enter the seniority is senior, right? We have said seniority is senior. What happens? actually nothing happens. The token gets stuck here because we have no condition, no else statement or anything modeled in this moment. So if the seniority is senior, so that's this S right there, we have nothing modeled for this, so nothing happens. All right, and if it's M, so medium, or like the seniority is medium, what happens? Exactly, we go down because here M was part of it. I hope this makes sense. This concept is quite hard to grasp, but I think we'll get used to it. Okay, so after the parallel, the either or, and the inclusive or, let's have a look now on the complex gateway. Also, this exists. The complex gateway. So let's say there is this gateway. It looks something like this, has a couple of lines, like a star. And of course, now multiple instances can come in, right? And let's assume it looks like this. So 3 paths coming in, 2 paths going out. And what does this actually mean or could mean? Let's say, for example, you send out that you're interested in a supply by suppliers, like to multiple. Like let's say you have 3 suppliers. You contact them, hey, I want an offer. And each of these lines could represent that there is an offer coming in from a supplier. But here you could now specify a rule on the complex gateway. Let's say the rule is, as soon as I got 2 offers, I move on. Right, so as soon as 2, I move on. So it could be like the first supplier is calling you, then this token is still stuck here, and as soon as a second one comes, let's say this one down here is coming, then you move on with the process. Hence, if anyone else would call this one here, like if this third supplier, right, it's this line right there, if the third supplier is coming to you, after you moved on, it doesn't matter to you anymore. Like it's gone, the thing is gone. Huh? So with a complex gateway, you can specify these kind of rules. For example, multiple could call you, you just wait until 2 of them came in and then you move on. Okay, that's the complex gateway. And now last but not least, let's have a look on the event-based gateway. So this is how the event-based gateway could look like. And as you can see, besides the sign that is different, also what happens next is different. Like after the event-based gateway, you need to have events right here in form of a circle. With the other gateways, you could have activities, things to do. And the event-based gateway right there is, so let's say something happens and we are at the event-based gateway. We actually wait for an event to occur. So it's not like the other gateways that you instantly do something, you wait for the time being. And based on the events you have made here clear, you're gonna wait. So let's say one of these events is a timeout event, so it's like a clock, a time. So let's say if 10 seconds pass, you move on. And the other one here is a signal event. So if a signal is coming to you, this could be an API call from somewhere else. And that's actually the thing, right? So you have the token here, you're gonna wait until one of these occur. Let's say 10 seconds pass, hence you will go this route, and this here is dead. So if the signal is coming after the token moved on, thing is over, right? The system is not going to react on this one. But if the signal is coming right before the 10 seconds pass, what's gonna happen? Exactly, the token will move on to the signal, and from here you can move on with the process. And that's the event-based gateway.
In this video, I'm going to show you the difference between BPMN XOR versus OR gateways. In the next couple of minutes, I will dive deeper into these 2 gateways and I will show you a real-life example for both. Let's jump right into it and let's start with the XOR gateway first. Imagine the following business scenario. We are working for a bank and we have the job to model the loan request business process. To keep things simple, let's assume that as soon as a loan request gets into our systems, the first step is to check whether the client who is requesting a loan has a positive credit score. So either the credit score is positive or not. When the credit score is positive, then the next step within our business process would be the approval. But when the credit score is not positive, then we reject the loan request. Let's model this scenario. We start with the start event, loan request received. As I said, the first task is to check the credit score. For sure, checking the credit score might be a complex sub-process because multiple systems might interact. But in this video, let's keep things simple because we only want to focus on the difference between the BPMN XOR and OR gateway. This is why I'm modeling the task with the plus symbol here. It shows that behind this task there is a lot more to come, an own process. Let's assume the process of checking the credit score returns a value that might be true or false. True when the credit score is positive and false for the alternative. With an XOR gateway, here illustrated with an X in the diamond symbol, we now want to check if the returned credit score is positive or not. If the credit score is positive, then we accept the loan. Also here, this is a complex task, that's why I'm using the plus symbol again. If the credit score is negative, then we reject the loan. After either way, the loan request process is done. Either accepted or rejected. Let's illustrate a possible workflow with a token. As the process gets triggered, we generate a token in the start event. From here, we navigate to the first task, checking the credit score. After doing so, we move to the XOR gateway and check the value of the credit score. For this process instance, we assume the score was positive, so we move on to accepting the loan request. This step might also take a couple of sub-steps because there might be many approval chains. After that, we reach the end event, loan request accepted, and this token gets eliminated. For the other case, let's illustrate that with the yellow token. We also check the score, but this time the score is negative. Therefore, we go the other path. Rejecting the request and terminating also this token is the next step here. Alright, after understanding the XOR gateway, let's jump to the OR gateway. Let's take an everyday example, like ordering food. Let's say this process starts when we notice hunger. Then we choose what we want to eat. For this example, let's limitate it for 3 alternatives like pizza, pasta and salad. We can choose 1, 2 or all 3. After deciding in our mind what we want, we are going to select these foods onto our order. We place the order, wait until we receive the order, and that's it. Let's model this scenario. The process gets triggered as soon as we notice hunger, so that's our start event. First, we choose the food. Now, as I said, we have 3 foods to choose from. We can choose 1, 2 or all 3 dishes. Pizza, pasta, salad. That's the inclusive OR BPMN gateway. The XOR gateway only allowed 1 path. Now we have to go at least 1 path. After selecting the food, we place the order and wait until it arrives. That's it. Now let's also walk this process through with a token. In our example, we choose pizza and salad. That's why the inclusive OR now creates a second token. If you would choose all 3 alternatives, we would have 3 tokens. When they join together again, we are with 1 token left. And this 1 token is going through the rest of the business process. So now you have seen 2 examples for an XOR and an OR gateway. Let's make a quick comparison between these 2 again. Like I said, the XOR is an either or, so only option A or the other one, only one is possible. OR is an inclusive OR. For the XOR, we have only 1 path that is valid, and for OR, we have at least 1 path, but multiple are possible. Also, the XOR gateway has only 1 token going out, but the OR gateway has multiple ones, at least 1. If you want more content about BPMN or business analysis related content, let me know in the comment section below. Also, feel free to hit the like button and the subscribe button if you don't want to miss out more of this content. Thanks for watching and take care.
Alright guys, today we're going to talk about the event-based BPMN Gateway. I got asked about the event-based gateway in the comments a lot, that this concept is quite difficult to comprehend in comparison to the parallel gateway or the either-or gateway. So today, let's focus on the event-based gateway. So as you know, how does it look like the event-based gateway? You know, generally gateways have this route form, the event gate has a circle, and then it has like 5 corners in it. And of course, this is a process, so something has to happen before and something has to happen after. So how do we actually understand the event-based gateway? What does it mean? As you know, let's go quickly to another gateway. Like I will take a different color. Let me take red for now. So when something is coming in and you have the XOR gateway, which looks something like this, as you know already, only 1 path can be chosen from you. It's either this one or the other one. And also, the decision has been made instantly. So as soon as you arrive here in this gateway, let me take a marker. So as soon as you arrive here in the either or gateway, instantly the process has to make a decision where to go. Do we go up here? Or do we go down here? Instantly. And this is actually the big difference to the event-based gateway. So let me erase this one quickly. So in the event-based gateway, what happens, so here again, there could be two or multiple paths, doesn't matter. When we arrive here, the first thing is usually we wait. We don't immediately do something. How is that, or when does this make sense? You could imagine, so after the event-based gateway, only events are allowed. So here's an event, and there's an event. This could be a signal event with a triangle. This could be a timer event with a clock, you know. And what happens here, as soon as the token from the process goes into the event-based gateway, the first thing is now we're waiting for one of these events here to occur. So the token will stay here in this position until one of these events occur, right? In the either or, we had instantly this decision. Here in event-based, we wait for the moment being. And like I've said, right now there are two possible events. First is a signal, so something is coming in, or a timer. You could imagine, for example, API calls, you know, REST APIs. So two systems are communicating with each other via an API. And what happens is you send a request. So we could do a process like this. So let's say in the beginning, there is an activity. That's like the API call we do. So we send something out, right? And if a lot of data is coming back, this API call can take some time, multiple seconds, maybe even longer, who knows? And we don't have the answer immediately, right? So what we do is we have an event-based gateway. So we do the API call. We go to the event-based gateway here, the token. Now either we get an answer back or we have a timeout. So let's say if no answer is coming back from the API, within 100 seconds, we do something else. We stop the whole process. So here, when the timeout occurs after 100 seconds, we do, I don't know, an activity A. But here, on the other hand, when it comes back, so there's this dotted line coming back, you do activity B or something totally different. And this is actually the key difference. This is how the event-based gateway actually works. So just to summarize it, we go into this gateway and then we have to wait until one of these events occur. With all the other gateways, like the parallel, the either or, we immediately jump based on what the decision is here. But with the event-based, we gotta wait for at least a very short amount, but technically we could also wait for some longer. And I also recommend, if you have an event-based gateway, to always also use the timer event here, because you have to schedule a timeout, because otherwise you just don't move on anymore, right? So it makes sense to have always the timer event here after an event-based gateway. I hope this helps.
Today I want to show you how I read business process models as a business analyst. For this, I've prepared a couple of diagrams for you, some which are quite easy, that's the starting level, then two which are more intermediate, and then I have a process model with me which is quite complex, and I want to show you how to read it effectively so you can understand any BPMN diagram in the future. Let's get started right away. The first one is a very easy one. So the first thing I do is, before I read any diagram, is first things first, is there a pool or are there lanes? So a pool you can see here, which is basically an organization or demonstrates a whole process. Then we have lanes. Lanes are roles. You can see here we have 3 lanes. So I know, okay, there are 3 actors or 3 systems in this process active. Then the next thing I want to see is, are there start or end events? A process could have multiple of them. For me, it's clear, okay, there's one start event here, and there are multiple end events right here on the right side. Also, it's a very good practice to As you know, BPMN is read from left to right, so the most left event should be the thing which is starting the whole process, and the most right events should be the end events. All right, very simple here. As the process gets started, we don't know how it gets started, and also the description start event is not very good, but let's not focus on these kind of like words. So when the process starts, we have activity A, very simple, and then we have the first gateway. As you see, this is the default gateway. So what does this actually mean? The default gateway is the exact same thing as the either or gateway, which looks like this, like an X. So this means only one path here will be chosen. You can see if condition 1 is met, we will go to activity B, C, and then the whole thing is done. But if condition 1 is not met, but condition 2 is met, we will go the way down here. What I always recommend is, because let's, for example, this is a check. Let's say, is the variable A equal to 1? Then we go this way. If it's equal to 2, we go this way. But what about the rest? If it's 3, 4, or minus something. So if I use an either or, I would always try to be a yes-no gateway, or I try to use the else, right? So condition 1 or else. So you cover everything. All right. So in this case, if condition 2 or else is met, we have activity D. Here basically we go to the next gateway, which is a parallel gateway, because here this plus means parallel. And what this means is now, from here, 2 tokens will be created. So this means the process will go this way and this way at the exact same time. So we have 2 tokens, activity E and activity F. Both will be conducted at the very same time. Now here in this case, of course, activity E or F could be quicker done or slower. For example, activity F could be done while the process is still stuck in activity E, and as soon as activity E is done, then we arrive here, and only then the full process is done. This could be as designed, but if you want to make sure that before the whole process ends, like you wanna ensure that activity E and F has to be done at the same time, and then the process moves on. What you would need to do is you need another plus gateway. Let's do it like this, and both activities would need to go in it, and then we could go to an end event or whatever, because this parallel gateway here would ensure we are in sync again with both these paths. Okay, this was one easy one. Let's move on to the next, also fairly easy one. So the first thing, as you know, what I've mentioned is always look out for pools and lanes. So we can see here, there is a pool, customer, and here is one, the bank. So we have 2 organizations, 2 processes coexisting. And within the bank, we have sales, head of sales, and the risk manager as roles here in lanes. Okay, again, I'm looking for start and end events. You can see on the left side, there is a start event, and here we have one end event. The customer here is a black box. So this is basically the process of the bank, and we assume the customer to be a black box. We don't know what exactly the customer does, but we know that he is going to, or she is going to communicate with us and is receiving something. Okay, so how does the process start? Here in the sales role, we have a credit request. So probably, as it seems, the customer is submitting something to the bank, to the salesperson. So we have a request for a credit. The salesperson is going to assess this credit, and now here's the first gateway. So after assessing the credit request by the salesperson, 2 things are going to happen in parallel, because again, there's a parallel gateway. So one token goes directly here, and one goes directly here. So after assessing the credit risk is done, the risk manager is going to assess the risks and simultaneously, based on the decision, are standard modalities applicable, yes or no? Let's say it's yes. So this means assessing the risk down here and calculate the modalities is happening in parallel at the same time by different roles. All right, now these things are not in sync, so one could be faster than the other. Let's say assessing risk is much faster. And for the calculate modalities, we need some days. So the process is still in here. Here's one token waiting in the parallel gateway. And as soon we are done here, we draw up a contract. And as soon this is done, now both tokens are synced again. And only then we send out an offer with a contract to the customer, and we end the process right here, right? So it's very important to understand that even if the assessing risk part is super quick, we will take some time because of the draw up contract. or calculate modalities or design special modalities based on what this condition here was. Okay, this is a fairly easy one too. Now let's jump to something more intermediate, and it could look like this. So for now, I'm not criticizing that there is no name for certain events. So let's skip this. Again, the same process, what are the lanes? Here you can see there are two different pools, actually, not lanes. These are pools. You can see these are pools because here is a gap in these two pools, basically. So we have two different processes, two different organizations. And between these organizations, we have message lines. This is these here, these dotted lines between message throwing events and receiving one. Okay, so let's start again. Where is the start of the process? Very simple. And where is the end? Technically, I can see multiple ends here. So let's go through it. The citizen is one role and the government is a different role. So what happens? The citizen is submitting an application. We don't know exactly how this is going to happen. This could be just going to the office of the government and handing over a piece of paper. It could be via an app. We don't know here. But what we know for sure is the citizen is submitting an application. Here's a throw message event with the application. So this is going to start over here. So basically, this event is starting this process down here. Okay, so that's the trigger. The government receives this application in whatever form, we don't know, and is going to review the application. So what is going to happen at the same time, maybe I was a bit too quick, when sending this application, the process down here gets started and the citizen is going to wait here in this event-based gateway. This means the citizen is waiting for two events to happen. One is this message here, and the other one is this message here. So if no message would ever come back, the citizen would wait forever based per this diagram. All right, let's go down here. Review application. So the government is reviewing it. And now is the question, is this application correct or not? If it is correct, then we move on to the activity granting license. And now what the diagram modeler did is he made two arrows going out of this activity, which he or she can do. I would generally not prefer doing it because very not too intuitively to understand. But what happens here is after granting the license successfully, two things happen, two tokens happen. So this process down here, one token will go to this end event there, and one token will go to this end event here. And while ending here, a message is sent up to the citizen. It's a bit, I wouldn't do it this way. I would do it a bit different, I guess. I would just mainly do one end event, maybe cancel this one and just have this here, and then it's fine, or using an activity send activity. But yeah, you can do it this way. I would just not go for it. Anyway, as soon as the granting license is done, a message is sent. Hence here, the citizen gets a notification. And as you remember here on the left side, we were in the event-based gateway and we were listening for one of the two events to happen. And this one here happened. All right. So the token from here goes to here. And actually then it's done. This is the end, so to speak, for this process. Okay, this is the process if everything was fine. This was the happy path, actually. So how would it look like if we did not have the happy path? Let me remove some things here quickly. It just takes a couple of seconds. All right, now let's go on with this. So when the application was not correct, so let me use a different color for this one. Let me use blue. So it was not correct. Hence, the request to complete application is sent over here. And basically here, two things happen now at the same time. The government body will be here in the event-based gateway waiting for an event to happen. And as this is a throwing message event, we're going to go up here. So what happens now? Two things are going to happen. First thing is, as the government is sending this message to the citizen, this event-based gateway token here will get down here. So the citizen receives this information that he has to correct something and asks himself or herself, will I complete this? Yes or no? Do I want to now complete the application or not? If we say no, we go to this terminate cancellation end event. What does this mean? The terminate cancel event is very special because this means as soon as we arrive here, we're going to kill all tokens in the process. So if you remember, we have a token down here on the government. This is going to get killed so that all instances are done. If you would have not determined an event, just a normal one, like up here, for example, this would mean that this token down here again would still be active forever and would never get cancelled, you know? So this is kind of like a zombie process then. And that's why we need to terminate here. Okay, let me clean up the diagram again for a bit. All right, that looks better. Cool. So if you assume the citizen says, okay, yes, I'm going to complete it. So we go to the complete application activity, and then we go again to a throwing message, which is going down here. And as we see here, there is this token from the government. And as we receive this message, the token is going to get here. And then you can see again the path going there. You're going to review the application, and then it's the same process as before. So this is totally fine. There's one case missing now, which we have to cover. And it is, let me use different color again. Let me use green or something. As you remember, we were waiting for feedback from the citizen. And whatever the citizen is choosing, let's say the citizen needs a lot of time to actually think about this. As you can see here in the event-based gateway, there's this receiving message, which we have above. Or if we don't receive, here you can see time to complete application. So there is a deadline, right? So the government is just waiting, let's say, for example, 7 days. And if you do not receive this message event here within 7 days, if we do not, then we're going this route down here, which means we're going to reject it, and also a terminate event. We're going to terminate all tokens. So basically also the token from the citizen up here is going to get killed. So the whole instance is done as well. All right, this was an intermediate level. The reason for this is because we now have event-based gateways with multiple pools which interact with each other. And we also have a termination. Okay, let's jump to the next flow. This again, I would say is a kind of like intermediate. The first thing again, you know it by now, I guess. What is a pool? What are the lanes? We can see this. What is the start and the end? Start, we have now 2 starts here. So I would mark them both probably as equally powerful, and 3 ends on the right side. Okay, we don't know how these things get started. There's not much context, but let's for now just assume the upper one gets started with a message here. So we do user task 0, task 1, very simple. Now we have an XOR gateway, so only one of these paths are going to be chosen. If we take the first one, so we accept something, we have a script, a service task, so this means that the system is doing something, and a terminate end event. At this point, a terminant or the normal end event doesn't make a difference, because as for now, as we can see, there's just one token. This could also indicate there's more to this process, right? If someone uses the terminate, probably there could be a different start, which means there are multiple tokens, but we will find out in a couple of seconds, I guess. All right, so if you assume, let me take a different color. We don't accept, we reject. So we are still at the top here. Then we have the service task, a user task. And now it gets very interesting because of this one here. This one means the following. So whenever the user is doing user task 2.2, you can see here is a timer event, which is intercepting. So kind of like there are 2 ways to model this. Here you can see a straight line, or you could see a dotted line, which is not straight. And as it here is a straight line time event, it means the following. Let's say we would add the connotation 10 minutes, okay? 10 minutes here. So this means when the user is doing user task 2.2 and the user takes 10 minutes, let's say after 10 minutes the user is not done, then we're going to go this route here, and we're gonna like take this token from here and go up. So we stop the activity 2.2 actively as soon as 10 minutes are arriving. If not, if the user is done within 9 minutes, let's say, if this is the case, I'm going to take a different color again. We're gonna go straight here. So this path up here is not gonna get chosen as soon as we are quicker than 10 minutes. And yeah, in this case, here's a parallel gateway. This is a problem now. This parallel gateway is a problem. Why? This means here are two paths going in, as you can see. And it's only going to proceed further if this parallel gateway receives one token from each path, right? And for now, we haven't gone the lower path here, so to speak. This means actively, I'll just take the, like this. So we are stuck. Right now, we are stuck here with one token. So we could say we are stuck here. And now maybe the different thing comes into play here down. Right, the second start of the process could be here. Very simple, do a manual task, a user task. Then you have a receiving catch event, but we don't know from where we receive it and what we do with it actually. Then we throw a message. There's also no detail. And then we go here. And only then, if both tokens are now here, then we can end this process and also send something out to someone. So that's the tricky thing here, right? Like, if the lower process doesn't get started and you get down this path here, you're gonna wait until both is happening. That's maybe the key thing down here. All right, and maybe this might now make sense why we do have a terminate event. Let me clarify why it now makes sense that we have one. I will quickly erase everything and make it clean for you. Okay, so if you assume for the moment being, the lower process gets started first. We go here, 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 as you've seen, and we're waiting here for a token. Let's say now here up on this top, the process is also starting. We go here, and we assume for now, we accept this. As you can see, we're gonna end up here. And if this would be a normal end event, the token down here would be still living. So the whole process instance will be a zombie forever. That's why we need to terminate up above, because then we're gonna kill this token too. All right, I hope this makes sense for you guys. This was a more intermediate one because we also have this symbol right here, which is now maybe new to you, but it's a great concept, right? Just to give you a reference, if this line was not solid, but it was like this a bit, you know, if it's like a dotted line, this would mean as soon as the 10 minutes arrive, we're gonna do this path, but the path down here is not getting killed or transferred. So both can happen at the same time, right? It's not interrupting, so to speak. Okay, so now let's jump to the last one. This is a complex one I want to show you. I hope you don't mind the quality of this. Again, the first things first, what are the lanes and pools I have? I can see here are a couple of lanes, couple of processes or organizations, 4 in total, 4 different pools. We have the purchaser, service provider A, provider B, and provider C. So where's the start? As you can see, right now it's a bit more hard to understand what is the real start. With a bit of experience, you can see that this one is the real one. But if I would model this, I would model it like this, that on the left side, this is the most left. And these start events, I would move more in this direction so I can see from left to right, which is the first. This is how I would do it. But anyway, so let's have a look what's happening here. So this process starts. We don't know how it starts, but the first activity is to request the quotes. So the purchaser is requesting quotes, maybe about some products or services from the provider. So you can see here is a message sent out. There is a message sent out. And also here is a message sent out. Oops. So actually this one is starting the 3 processes around. This also makes clear that this one has to be the start event. All right, so the quotes are sent out. What happens is our purchaser here is going to go into this multiple parallel gateway, and 1 token will be sent out here, 1 here, and 1 here. What this means is we are now waiting for these events to come back because these are catching message events. And if you look at any provider, let's look at provider A up on top. What it does is actually this process, they receive our request, they send a quote, and then they're done. That's it. So and when they send the quote, we receive it here. Now every provider could be more quick or more slow, it doesn't matter, but they're gonna send something. And as you can see here, we have the complex gateway. What is a complex gateway? A complex gateway is whenever you cannot use a parallel either or gateway, you're going to use the event-based, you're going to use the complex gateway, because here you can define the rule very individually. Maybe you cannot read it, but here it says 2 of the 3 quotes are received. So this means actually we sent 3 requests, you remember, provider A, B, and C, and we're gonna wait for 2 of them to come back. So let's assume provider B was quick, and provider A was quick, but provider C was sleeping. So we got 2 of the 3 and we move on. So we move on with this activity here, assess the quotes. So it doesn't matter if C is sending his or her quote anytime soon, we moved already on, we are out of it. So it's like lost. So we assess the quotes of A and B, and then we look, are we sufficient? Is this sufficient? Yes or no? If no, we're gonna go back. That's the path up here. We're gonna go back, and then we do the same thing. Wait until we get 2 of 3, and we're gonna request them. But if it is fine, we're gonna end up here, and this is again a termination. We're gonna kill everything, every instance, because we're done. We have a rate. We don't need anything to come back with us, so we terminate. So this is now the more complex one. Of course, there are even more complex diagrams, but this is it for today.
How to optimize a business process as a business analyst with these 5 simple techniques and BPMN. Let me show you. Let's assume we have this following process here. It's very basic. It just performs a couple of tasks. The very first step we could do to optimize this business flow is by eliminating a task. So maybe we find out a step in between is absolutely not necessary, or we can delete a couple of things within the step and make the process more lean in this case. This is totally possible, and in practice it also happens that we have steps which actually don't provide value. The second technique or second way to actually improve a business process could be vice versa. So if you assume that's the as-is process, the target process could look like this. So putting a step in between, because for example between do A and do C there's so much of a gap that having a do B step in between could optimize the flow in terms of reducing the time needed or enhancing the quality. The third thing we could do is actually outsource a task. So for example, let's say this pool here, this lane represents our company, and we could just quickly do it like this, that we say, okay, we don't do step B internally, but what we do is we outsource it. Hence, we actually could model it like this. So what this means now actually is that we do A, then we give maybe a notification to a vendor, the lane is a vendor, and the vendor does something for us and gives us the information, and then we do C. So we have just outsourced a task. Then again, the fourth way to optimize a business process could be again vice versa. So if you assume this is the as-is state, we could kill the interface to the vendor. So we would just kill it here, and maybe it would be like this again. Maybe we'd need a do B step in between, and we're actually back. So we have not outsourced it, we have insourced it again. And the fifth way to actually optimize a business process could be by swapping tasks. So maybe it does make more sense to do C before B. So we have just swapped these tasks from the order perspective. And sometimes it does make sense to change the order, because if we do it, maybe some follow-up steps get easier or faster. This could be one way. Then there is also a bonus way, a sixth way. It's kind of like similar to outsourcing, but maybe in a different way. Maybe we do not want to outsource to a different company, but let's say we have internal employees, some different roles. We could maybe outsource it to someone else within the company, if this makes more sense and makes the process more higher quality, faster, or maybe lowering costs. So these were 5, or let's say 6 ways to optimize a business process as a business analyst.
In this video, we are going to build an application in just a couple of minutes with only BPMN. Let's assume the following use case. You are the business analyst of a bank, and the bank has the following use case. it is possible that clients make a phone call that they want to change their banking product. So let's assume they have a portfolio right now. Let's say they're investing in stocks and only in the US, but they want to change their portfolio so they also have some European or Asian shares, whatever it might be. That's the use case, right? We want to build an application where a user of the bank can change the product and maybe also trigger a rebalancing, and also that another banking employee can check the order. And this is how the BPMN diagram could look like. You can see a pool. So the big pool here is the product change and rebalancing process. And we have three roles. The front employee who's entering the first data, then the operations team member who's checking the order if everything's all right. And then we have also the system that is doing some stuff in the background. All right, how are things getting started? In this process, just to be simple, we assume the start event here is a phone call received by the front employee or the advisor. And the very first step here in your business analysis could have been that always the front employee has to search for a customer. So actually, the user can search for customers until they have found a customer. Could look like this. This loop here means only when we find a customer, we move on. Then we do the adjustments, meaning changing the product and maybe other fields we have to fill in. After this is done, the operations employee has to check the order. And here we have an either or gateway asking for the outcome. What is the outcome of the check? We can see here there are two scenarios. One is rejected, so the employee here is rejecting this case, then the case is rejected, and maybe we send an email out or something. And the other case is approved, so everything is all right, meaning we have an update data here, and the data is updated. And this activity is done by the system. So this is going to be an automated task like this, but for now I have to model it like this as a user task, because in the engine, because I didn't have anything backed up right now, it would give me an error, but for demonstration purposes we leave like this. Before I show you the details of these activities, what I have coded and parameterized, let me show you in the UI how it looks like. When I click the button here, I'm deploying this diagram, and you can see here the activity, or here this token is in search customer, and here you can see search customer as an activity. All right, let's claim this one. I have built the following mask, so you can search by customer number or maybe first name, last name, birth date. The customer number is 66. In this step, I'm just completing this step. And then the next step is here, make adjustments. As you remember in the BPMN diagram, the next one is make adjustments. I can update here. You see the token just moved. So we go into this one. Let's claim this activity so we can do something. All right, so the current product here is product C with 100% Asian shares. And now we want to change the product. Right now, there are just two products backed up. I have hard-coded these. Of course, in a practical example, in real life, you would maybe have an API call to get all the products which are there. Let's go for this one here. We want to have a 50-50 share between Europe and US shares. And there's the question, do you want to rebalance immediately? So when we change from Asian shares to this portfolio here, of course, the securities have to be sold and rebalanced. And if unchecked, rebalancing to the new portfolio will happen next Wednesday. So we can now decide, do we want to do this change immediately or just for the next day or whenever Wednesday is? I make yes, so I want to do this immediately. I just complete that. All right, then check order. Now for demonstration purposes, I can do all the activities, but in practical examples, in real life, another user should do this now. So they have a check, for I check. Let's claim this activity. Here in the diagram, you can see where we are right now in the process. And there's a question, what is the outcome if I check? Is everything all right? So here you can decide to approve or to reject. Both is possible. Then we can see the product change for customer 66. That's the variable from before. The old product was C, Asian shares. The new product is B, 50-50. And with immediate rebalancing, yes. So based on this, we can either approve it or decline it. Let's have a look on the diagram. What happens when we reject it? Nothing. The diagram will end. But if we approve, we have to update data activity. So let's try for testing purposes to approve it and complete. Now I would assume this activity to be update data. And yes, it's the case. So when we go in this, we have nothing modeled here. That's why nothing special is happening. But you can see we're here at the end. So let me show you in this tool how I made these forms so you can see what is the difference here. So first of all, search customer.
Here on the forms section, you can see these fields, right? Customer number, first name, last name, birth date. These are variables I have defined. You can define if it's a date, if it's a string, whatever it might be, right? That's how it is here. And make adjustments. I have the variable new product, current product, and with rebalancing. The new product right now is just an enumeration. Like I said, for demonstration purposes, in real life, you would make an API call or something like this, or have a CSV file configured. So that's an enumeration, right? You have to select one of these. The current product right now is hard-coded Asian shares. And with rebalancing was a Boolean. That's a checkbox, yes or no. That's simply it. And you always have to remember here these variables, because these I'm going to use in the next activity in check order. So here you remember, for example, the customer number here. I'm just taking the variable from the very first step. Here it's called customer number. And here it's just called dollar, then the brackets, customer number. So I use the variable from before because I want to display it. The same for the old product and for the new product and for rebalancing as well. I just reference to the old variables. That's why I have been able to see it. And then, of course, in the either or, we are checking now about the outcome. As you can see in the activity check order here in forms, there's an attribute outcome of check. An outcome of check is an enumeration, approved and rejected other values based on what I choose in the dropdown. And this is now important here. This idea has to be remembered because here on the path, if I click here, there is this expression, right? So when do I go this route? I go this route if the outcome of check, so that's the variable before, equals rejected. And if it's equals approved, I go the route down here. That's how an either or looks like in the parameterization or in the coding section of a BPMN diagram. Exactly. So this here just shows you in a couple of minutes I have been able to build a very simple application with just BPMN knowledge and maybe some know-how about parameterization, but that's about it.